know what it's time for?
Remember
Practice
to find
time.
the axis of symmetry. We use x equals negative b over 2a. A is equal to 1 in this first problem, and b is equal to negative 10. When I substitute, notice I have two negatives. This is going to turn out to be a positive result. So this is going to be 10 divided by 2, which is a 5. I'm going to use, all right, I'm going to go ahead and substitute in the 5 in here. Solve this algebraically. So 5 squared, this is going to turn out to be a 25 minus 10 times 5 is 50 plus the 2. We're then going to go ahead and subtract. So 25 minus 50 is going to become a negative 25 plus a 2. So f of 5 is going to give me a negative 23. So that means that my vertex is at 5 comma negative 23. And this is why function notation is nice, because you can see the input right there. I'm going to follow the same process. So our vertex for number 2 ends up being 2 comma 16. And the axis of symmetry is x equals 2. Notice they have the same x values. We have 3 negatives on number 3, so that means that our answer is going to be a negative result. Remember that y is the same thing as f of x. Negative 2 squared is negative 2 times negative 2, which turns out to be a positive 4. A positive 4 times a negative 2 is a negative 8. A negative 8 times a negative 2 becomes a positive 16. Add the 5. Add from left to right. The vertex is at negative 213. All right, so here we have two negatives. That's going to turn out to be a positive. X is equal to 1. This is our axis of symmetry. One squared is 1 times a negative 3. This is a negative 3 on this side. 6 times 1 is just 6. Add the 1 at the end. We're going to go from left to right. Negative 3 plus 6 is a positive 3 plus 1. We get a 4. So when our input is a 1, our output is a 4. Therefore, the vertex in this case is 1 comma 4. I hope you guys are getting this. If you have any questions, start getting used to using WebEx to ask me questions. I'm normally checking my emails and WebEx often, so don't be afraid to reach out to me. It's time to graph. Now you can use desmos.com. I won't have an issue with that, but make sure you guys know how to graph the old-fashioned way, which means you make a table and you graph your points. Pick points. I just start with 0, 1, 2, 3, and if I need more, I adjust. So if you want to, go ahead and go to Desmos, but I'm going to also demonstrate how to graph by hand. So I'm drawing my vertex first, down here. All right, so I know that the vertex wasn't perfect before, but I'm just kind of trying to work this out here as I go along with you. And this is the right side of my parabola. Here's my vertex or my minimum. The minimum value is -1. I'm going to go ahead and mirror image on the left side. So I'm going to go equidistant here. So that's going to be here. And this should be right here. And there's our parabola. So now we're going to determine what our domain is. So remember, domain goes left and it goes right. So how far left is this going to go, the parabola? Hopefully you can tell that it's going to go forever in the left direction and it's going to go right forever in the right direction. So we can say the set of all real numbers. All real numbers. Don't forget that. Oops. I can spell, I promise. The range is your y's. How far up and how far down. Those are your y coordinates, your possible y coordinates. So if you notice, we have a limit that is going to be right here. We can't go lower than this point. That's our vertex. We can only go up. So this number right here, that -1, that minimum value, our range is going to be anything greater than or equal to that -1. Not this x value. We're looking at the y because we're talking like height. Think of range as height. For time's sake, I'm going to go ahead and do this one in Desmos, and then we'll talk about the domain and range. -1. All right, so if you look, we can see our 2 zeros are right there, and my vertex is down here below. As you look at this, the domain going to turn out to be forever left, forever right, so all real numbers again. The range, this parabola is opening up, so because of that, this is our lowest point. What is that minimum value down below? So these are, the x's are going by 1s, the y's are going by 1s as well. So you can see this is at 2. This is going by 1, so -9. That means that my y has to be anything greater than or equal to that -9. It has to be greater than, all right, because it goes upwards. If this was upside down, this symbol would be less than. All right, I hope you can pause the video and you try number 7. Use Desmos, it's okay, don't stress. Just remember domain and range, we've done this before. All right, so here is the other graph. And you can see it opens upside down. Why? Because of this negative right here, right? That's your reflection in the x-axis. The rest of the stuff is going to shift it. And you can see this is your vertex up here, our 2 zeros, or x-intercepts. Can you guess what the domain is? Take a risk. All right, we're going to pretend this is like Dora or something. Hey, kind of look like her. What's the domain, you guys? I can't hear you. What? Oh, wait, that's SpongeBob. All real numbers again, right? All right, because this goes forever left, forever right. The range, this time, we have a maximum value up here. This maximum is going to be the highest point of our parabola. So that means that the range has to be less than or equal to, and whatever that value happened to be. I didn't pay attention to it. 6.25. 6.25. There we go. And that's your range. Don't complicate it. You can do this. I believe in you. Do you guys think I don't know you can use Desmos? Of course I do. But we're going to go old school. We're going to find the minimum value or the maximum value by using our x equals -b/2a. Also, by just looking at the equation, can you tell if this opens up or down? So number 8, does it open up or down? Right there, guys. Right there. And I hope you said it opens upside down. So I'm just going to make a quick little sketch, which means I'm going to have a maximum value. And now I have to find what it is. I get that you guys don't like fractions, so I just turned this one down here on the denominator to a -0.5 times a 2. Notice there are 3 negatives, so that means that your final answer is going to be a negative. And if you double a half, I hope you guys understand that becomes a 1. So x is going to be a -5. My goodness, this lag. All right, so it's a minimum value because this parabola opens up, so it's got to have the lowest point. When you find the x value, substitute that back into your equation given to you. Use PEMDAS on the right side, and then when you get your output, when your input is -1, your output is -10, which means your minimum value is at -10. There are 3 negatives, so here's the negative that has to do with the equation -b/2a. Here's your b value, which is negative, and a is also negative, so there's 3 negatives, which means your answer is going to be a negative because these are odd number of negatives. And 4 divided by 2 is 2, so it's a negative, so x is equal to a -2 for my x coordinate. By the way, this opens upside down because of this negative right here. So that means we're going to have a max. All right, so I'm going to go ahead and substitute in my -2 in for x because that was my x-coordinate of the vertex. Remember that the axis of symmetry and the x-coordinate of your vertex happen to be the same value. I ended up getting a -3 once you do the PEMDAS on the right side of your equation, which means that because this is a parabola that's opening upside down, we have a minimum, I'm sorry, not min, a maximum value of -3 through the process. The 7s are going to cancel out, which gives you a fraction of 1/2. All right, so our x value of our coordinate is going to be 1/3. All right, so we've got 2 negatives, so this is going to turn out to be a positive result. I know this sounds like something you don't want to listen to. This is a complex fraction here. So what are 2 copies of 1/4? 2/4. Well, 2/4 becomes 1/2. X is going to turn out to be a positive 2. 1 divided by 1/2 turns out to be 2. Okay, so 2 squared is 4. 4 copies of 1/4. I hope you guys can hear it and see it visually. It's going to turn out to be a 1. But because there's a negative, this will be a -1 for this entire thing. Plus the 2 that we inserted here or substituted earlier, minus a 6, so -1 plus 2 is 1. Minus 6 is a -5. So our maximum value for this last one is a -5. That's what your y ends up being. And if you can go into Desmos, pause the video, type this in, and manipulate this. This is why I love Desmos. Okay, so now as we look at this, we're going to look, oh, come on. We're going to look for the highest point, that's our vertex, but we wanted to know the function here represents when a rocket is launched, and we want to know the rocket explodes at the highest point. When does the rocket explode? So we're going to be looking for the maximum value. So let's go back, and I'm just going to take a picture of this because, all right, as we look at this, it explodes right here. So when? The question is when. This is where students fall apart. It's not asking where, it's not asking for the height, it's asking when. When means time, and that means that we are looking for seconds. So in this case, the time is at about, so I'm going to say about 7.8 seconds. The next part's asking us at what height does the rocket explode? So let's just round it off and say at about 976.6, and we're talking feet. Don't complicate this. We can use Desmos. Remember how to factor. Do your best.